Okay, good morning to everyone. Uh, the previous class, we were discussing about the dissolved oxygen. How exactly this dissolved oxygen is very important in aquatic systems, and we already studied that how exactly the DO is interlinked with the temperature. With all these details, um, we'll go ahead with uh, the what are its environmental significance. That also we have discussed, um, but still we'll highlight the very important points that are required um, for the importance in aquatic systems as well as the environmental significance of this dissolved oxygen. So, so in a nutrient-rich water body, the dissolved oxygen is quite high in the surface water due to the increase in the photosynthesis. This is very important. If I say it is a nutrient-rich water means, so there the plants will grow. Best example is water hyacinth. If you take the water hyacinth. So if it is there in the water, we can say that some of the nutrients are also more, and it will give some of the photosynthesis. Once the photosynthesis is happening, of course, there will be a slight increase in the dissolved oxygen. However, some of the dissolved oxygen tends to deplete in the deeper waters. This is very important. You can ask me in the other way. If we go into the deeper waters, the light will not penetrate to that much depth. Once the light will not penetrate to that much depth, normally the photosynthesis will not happen. Once this photosynthesis will not happen means the dissolved oxygen, of course, it is going to decrease. Even some of the small plants in the deepest of the oceans as well as the rivers, it will go, but which does not produce that much oxygen that is required for the water body. So very less. So the best example, some of the dead phytoplanktons fall towards the bottom using of the oxygen as it decomposes. Once the decomposition is happening, or if you are getting any smell in any of the rivers or the pond, you just assume that the DO is go on decreasing in that body. So in a nutrient poor water body, there is usually less difference in the dissolved oxygen from the surface to the bottom. This difference between the surface and the bottom waters is exaggerated in the summer in reservoirs, stream pools, and some of the embankments when the thermal laying occurs, which prevents the mixing. So I already said that uh, the link between the DO versus the temperature both are inversely proportional. Normally during the summer season, um, even the mixing is also very less, and there is a lot of stagnant of chances of the stagnant water that is going to present or that is going to mix in the pond. This stagnant water uh, definitely decrease the dissolved oxygen that is present in the water, because there will not be any fresh water coming in and going out. So then, as the water level in the pond go on decreasing, even the dissolved oxygen is also go on decreasing. So this is what is going to happen in the temperature. As the temperature go on increasing, it has its own effect on the dissolved oxygen. Um, The surface may become sometimes supersaturated with oxygen that is greater than 100%. If I say it is saturation, I already said that the saturation temperature maximum we can expect 14.4 milligram per liter. The bottom, the normally we can, when the oxygen is not there, that we can call it as a anoxic condition. Sometimes the surface, maybe if you see any of the pond, if you see the surface portion of that one, maybe it will be super saturated with a dissolved oxygen. But as it go on um, going down towards the depth of water um, and the deeper sections, sometimes it may create the anoxic conditions. If I say it is the anoxic conditions, it is the absence of oxygen in this portion. At the bottom, you can say that there is an anoxic condition due to the one thing is that the photosynthesis is not happening there, and one more is due to stagnant water that is also possible. There, the anoxic condition is going to happen, and there will be a no oxygen that is present in water. If you think about the uh, uh, deep pond and the shallow pond, deep pond as well as the shallow pond, there's a lot of differences there. In the shallow pond, you may get some sufficient dissolved oxygen, but here it will be very less. Shallow pond, you can the whole surface of the water is exposed to the atmosphere. Once it is going to exposed to the atmosphere, normally we will get the higher percentage of oxygen that is compared with the deeper ponds. Some of the shallow reservoirs, then actively flowing shallow streams, generally are kept mixed due to the wind action in the shallow reservoirs and physical turbulence created by the rocks in the stream beds. Of course, whenever the shallow and the flowing water is there, we may not feel that the dissolved oxygen is flowing. As it moves towards the down, normally the oxygen that is present in the water will go on increasing. So then, organic matter, we will discuss this in the next class. How exactly the organic matter or the food that is going to make the changes in the the river water. So one is we already discussed that the relation between DO versus temperature. Now we'll discuss how exactly the DO versus BOD, then how exactly it is interlinked with the temperature, and how exactly it is interlinked with the organic matter. Organic matter. So we will discuss this part in the next class.